Simplify each expression. A, 3 over x minus 5 over x plus 2 plus x over 2. First, we'll identify the common denominator. So the least common denominator for this first expression, well, we need an x from the first fraction. We need an x plus 2 to handle the second fraction, and we need a 2 to handle that first fraction. So it looks like the LCD will be 2x times x plus 2. Let's space this fraction out a little bit more so we can see what's happening. So we've got 3 over x. I'm going to leave plenty of room in here. And then 5 over x plus 2. Again, I'll leave plenty of room. And then x over 2. So to get a common denominator among these, we're going to multiply each fraction by what's missing. So in the first fraction, I can see we have the x, but we're missing the 2, and we're missing the x plus 2. So we're going to multiply the top and the bottom both by what's missing, 2x plus 2. Okay, next fraction. I see that this one has an x plus 2, but it's missing the 2 in the x. So we're going to multiply the bottom by 2x, and we're going to multiply the top by 2x. If you look at the last fraction, this has the 2, but it's missing the x, and it's missing the x plus 2. So we'll multiply by x plus 2 on both the numerator and denominator. Okay, let's rewrite what we have. The first fraction is now 6 times x plus 2 over 2x, x plus 2. The second fraction has the same denominator, so I'm actually going to make this one single fraction and combine like terms in the tops. So for the next fraction, we've got minus 5 times 2x, so that's negative 10x. And the last fraction is x squared times x plus 2. Next up, we'll distribute through to get rid of those parentheses in the numerator. So if we distribute through here, we've got 6x plus 12. The next term is minus 10x. And then for the last one, we'll distribute the x squared through. So x squared times x is x cubed. X squared times 2 is 2x squared. And this is still being divided by that common denominator, which is 2x, x plus 2. Then we'll combine like terms up in the numerator. So I see that the only cubed term we have is x cubed. That takes care of this one. Then we go to the squares. The only squared term I see is 2x squared. Then we go to the x's. So we've got minus 10x plus 6x. So if we combine those together, that's minus 4x. And the only term left is plus 12. And this is being divided by 2x, x plus 2. Part B. We have the fraction x squared plus 5x plus 6 over 6x minus 30 times 3x minus 6 over x plus 3 divided by x squared minus 4 over 5x minus x squared. Before we move on to any of the other parts, the first thing I want to do is take care of this division. I want to rewrite this as multiplying by the reciprocal. So that means x squared minus 4 goes in the bottom, 5x minus x squared goes on top. So we've rewritten this division as multiplying by the reciprocal. Next up, we've got to factor every fraction or every numerator or denominator we see, and then we'll see what's going to cancel. So for this first fraction, x squared plus 5x plus 6. I don't see any common factors, so I'm going to go for two sets of parentheses. We can probably write this as the product of two binomials. X squared is x times x. And now I'm looking for two numbers that multiply to 6 and add up to 5. So that would be positive 2 and positive 3. In the denominator, 6x minus 30, I see that these both have a 6 in common. So if we factor the 6 out, what's left in the parentheses would be x minus 5. Next up, 3x minus 6. These both have a common factor of 3. If we factor the 3 out, in the parentheses, we're left with x minus 2. In the denominator, x plus 3, there's no common factor, and there are no exponents, so I know this is already factored completely. We're going to leave that as it is. Then we move on to this last fraction. The numerator, 5x minus x squared, they both have an x in common, and we're left with 5 minus x in the parentheses. And then finally, x squared minus 4. There's no common factor, so we're going to write this as the product of two binomials. And we can see it's a difference of squares. X squared minus 4 we can factor as x plus 2 times x minus 2. Next up, let's see what reduces. I like to go one factor at a time across the numerator and see what it can reduce with in the denominator. So first up, we've got x plus 2, and we search in the denominator, and we've got another x plus 2 down here. So these will reduce out. Next up, we've got an x plus 3 in the numerator. We've got an x plus 3 in the denominator. Those are going to reduce out. Next up, I see we have a 3 in the numerator, and we have a 6 in the denominator. So we can reduce those. We can divide this by 3, which will leave us with 1. We can divide this by 3, which will leave us with 2. Next up, we have an x minus 2 in the numerator and an x minus 2 in the denominator. So these will cancel out. This is starting to get a little cluttered, so let's rewrite what is left in this fraction. So we've got 1 over 2x minus 5. Right, that's all that's left for the first fraction. The second one, we've got 1 over 1. The last one, we've got x 5 minus x over 1. Now, I hope your eye is drawn to the fact that we've got a 5 minus x and an x minus 5. We should be able to do something with these. The problem is the order is backwards. These are kind of written in reverse order. So I want to first rewrite this. 5 minus x is the same thing as negative x, right? The x was negative, and then plus 5. So these are the right quantities, but they have the wrong signs to cancel what's in the denominator over here. So I'm going to go one step further and factor out a negative 1. If you factor negative 1 out of negative x, we're left with x. If you factor negative 1 out of 5, we're left with minus 5. So let's rewrite this. We've got 1 over 2x minus 5 times x times negative 1 x minus 5 over 1. And now I see the x minus 5s are going to reduce out. So all we're left over with in the numerator is negative 1x. In the denominator, 2. So negative x over 2. C. 6 over 2p minus 4 over p minus 2 plus 1 over p squared minus 4. Since we have additions and subtractions, we're going to need to get common denominators. In order to do that, though, we're going to have to factor up each of the denominators. So this first one, I see that these both have a 2 in common. So you can factor the 2 out, and we're left with p minus 2. This middle fraction, the denominator has no common factor, no exponents, so this one is already factored completely. This last one, p squared minus 4, there's no common factor, so we can go with 2 sets of parentheses. In fact, this looks like a difference of squares, so we can factor as p minus 2 times p plus 2. Before we get a common denominator, we can reduce a little bit, because I see that we've got a 6 in the numerator here, so we can reduce these. 2 goes into 6 3 times. So let's rewrite what we've got so far. 3 over p minus 2, I'm going to leave some room, minus 4 over p minus 2, plus 1 over p plus 2, p minus 2. So it looks like our common denominator, we're going to need a p minus 2 for this first fraction. We're going to need a p minus 2 for the second fraction, but we already have that listed, so we don't need another one. We need a p plus 2 for the third fraction, and a p minus 2, which we already have listed. So there is our common denominator. Next up, we're going to multiply each fraction by what's missing. So the first fraction, I can see we've got p minus 2, but it's missing the p plus 2. So we're going to multiply the numerator and denominator by p plus 2. Next fraction, the same thing happens. I see that we've got the p minus 2, but we're missing p plus 2. So we're going to multiply numerator and denominator both by p plus 2. The third fraction actually has both pieces that we need, so we don't need to multiply this by anything. Now let's rewrite what we have. We can distribute through here, so we've got 3p plus 6. On the next fraction, when we distribute negative 4 to both terms, we've got negative 4p minus 8. This last fraction, we don't need anything, so just plus 1. And this is all being divided by this new common denominator, p minus 2, p plus 2. Let's combine like terms in the numerator. So we've got 3p minus 4p will give us negative 1p. Then we'll combine the numbers. So we've got positive 6 plus 1 is positive 7. Positive 7 minus 8 will give us minus 1. And this is still being divided by p minus 2 times p plus 2. Now we could leave the answer in this form. Alternatively, you might want to factor a negative 1 as a common factor out of the numerator to leave this as negative 1 p plus 1 over p minus 2 times p plus 2.